So in this segment we are going to see a couple of more examples. Okay, so a student is trying to prove that the proposition p, q, are all true, and she proceeds like as follows. The fact is that if p is true, then q is true. If q is true, then r is also true, and if r is true, then p is true. Now from all of the facts, she is trying to say that pqr are all true. Okay, now the purpose of studying argument is that by knowing all the facts, by knowing all the statement, we can figure out that whether the argument someone is making, whether this is a valid argument or not, or we can make a valid argument by having all the true statement. Okay, now given the assumption, given the hypothesis, we can find out whether pq are all true or not. So how we can represent this argument like that? So p implies q and p implies q is true, q implies r is true, r implies p is true. That all of our assumption or hypothesis. Now conclusion is p is true, q is true, and r is true. Okay, how can we find out whether this is valid or not? So obviously we can find out using truth table. So we can see that we draw the truth table, all the combination of p, q, and r. Okay, so the case where all the assumption is true, this is one case. All of them are true. Okay, and this is another case where all of them are true. But we found one case when all our assumption is true but conclusion is not true. So to prove an argument is not valid, we just need to find one counter example. Okay, when all our assumption, all our hypothesis is true but our conclusion is not true. So let's see a couple of other examples. Say we are arguing that if p then q. Okay, means we are saying that p implies q is true, then q is true. Okay, then p is true, if this is a valid argument. Okay, draw a truth table. Let's find out pq, the case where both of the hypothesis, assumption or hypothesis is true, is we can find out this is the case. Okay, and this is also the case. Okay, we found out two cases where both of our hypothesis is true. Okay, but for the first case our conclusion is true, but our second case conclusion is false. Okay, so because of this case you can say that this argument is not valid. So if p implies q, if p then q, okay, then q is true, that means p is true. This argument is not valid. So let's see an example here. In this case our hypothesis is true but not conclusion. So let's see, if you are a fish, you drink water. Okay, so p stands for you are a fish and q stands for you drink water. Now q is true, you drink water. Does that mean that you are a fish? Many of other animal can also drink water. Okay, we drink water. Now if p is true, then q is true, we know that. Now you drink water, q is true. Okay, does that necessarily mean that you are a fish? We cannot make a valid argument like that. Okay, if q is true, that doesn't necessarily mean that p has to be true. Okay, another examples, if p is true, then q is true. Okay, now p is not true. Does that necessarily mean that q is not true? Okay, let's draw a truth table. We can find out two cases when both of our assumption or hypothesis are true. Okay, so both of our assumption and hypothesis are true. Now for the one case we find out our conclusion is not true. Okay, one case our conclusion is true, but we can find out, we can see that there is one case when our conclusion is not true. Okay, that means that proof that our argument is not a valid argument. So let's see whether we can see an example. If you are a fish, you drink water. Okay, P stands for you are a fish, Q stands for you drink water. Now you are not a fish. Does that necessarily mean that you do not drink water? If you are not a fish, that doesn't necessarily mean that you do not drink water. Okay, if you are a fish, you will drink water. Okay, but if you are not a fish, that doesn't necessarily mean that, which is not P, that doesn't necessarily mean that you can make an argument that you do not drink water. If you make an argument that you do not drink water, that's not a valid argument. Okay, all right. So we leave one for class practice. That's somehow a big example, that's a big exercise. So we are trying to make an argument here. So if birds are flying south and leaves are turning, okay, then it must be fall. So we are saying that fall brings cold weather. Okay, now the leaves are turning but weather is not cold. Okay, so until this is our hypothesis. Okay, if the birds are flying south and the leaves are turning, then it must be fall. So if this is fall, that means fall will bring a cold weather. Okay, fall brings cold weather. Now the leaves are turning but the weather is not cold. This is our hypothesis. Now we are making an argument that therefore the birds are not flying south. This is our conclusion. Can we prove that this conclusion is true? Birds are not flying south. Okay, so I'm leaving this as a class practice. So make some simple statement like P, Q and R. All right, and then make some hypothesis using those elementary statement. All right, make some hypothesis. All right, try to prove that if all the hypotheses are true, whether our conclusion birds are not flying south is true or not. Okay.